Making an actual vending machine is not that easy. Its technology is very advanced and complex engineering behind this. As you can see, it's huge of size. Right now, they're using online digital payment system here. Though it's have an actual real payment system, it doesn't work 100% accurately. That's why they included online payment system. They given a touch screen to select and confirm any product and also the payment method. So in this video, I'm going to make a vending machine by using STM32 blue pill. So our vending machine will just a sample of this and how it works. So I'm Rahad, you're watching Logical. Let's back to the studio. To make this project, you need some necessary components. A microcontroller STM32F103C8T6, which is known as blue pill. 4 eye sensor module, which is made by me. Click on this I button to watch that video. A LCD display. 4 DC yellow motors. 2 L29 3D motor driver IC. 3 5 volts voltage regulators. You need more components down here. I made these springs out of GI wire for product lineup. It will attach with the motor. To make this, you need 14 size of GI wire. I wrap it on a perfume bottle and make shape of springs. For holding the spring, I cut a plastic board like biscuit shape and make 3 holes. This middle hole for attaching with DC motor. After that, I tied it by screws with the spring. The motor will connect with the spring like that and it rotates smoothly. Nice handwork! Now I will explain and demonstrate this project parts by parts. First of all, I'm showing you how to control DC motor by using a PWM mode of STM32. To control a DC motor, you need a motor driver IC because the STM32 blue pill cannot provide that much current to operate a DC motor. I'm connecting a DC motor with the motor driver. This is the circuit diagram for controlling one motor. So this PWM signal input pin must be connected with the microcontroller. If I connect this pin to positive 5 volt, it will rotate. So need to connect the microcontroller and generate a PWM signal from it. Create a new STM32 project in STM32 Cube IDE software. Searching the model number STM32F103C8T6, double click on it to create a new project. Name this project and click finish. So now need to configure some parameters here. Go to timer, then under theme 1, choose PWM generation at channel 1. As you can see, the pin number A8 has been configured as PWM signal output. Now go to system core, then RCC, set high speed clock to crystal ceramic resonator. After that, go to clock configuration, select system marks to PLL clock, set PLL source marks to high speed external oscillator, which is HSE, and also set PLL multiply by 9 times and APBI prescaler by 2 for generating 72 MHz clock. Need to save this configuration by pressing Ctrl+S on your keyboard. It will automatically ask you to generate the code, or you can simply click on build to generate the code. The main.c file will automatically open in another tab. If not, simply go to Project Explorer. Under source folder, you will find the main.c file. To start the timer channel 1, you need to write this code under user code begin. In main while loop, need to declare the value of CCRX. The CCR maximum value can be 65535, which indicate maximum 3.3 peak voltage output. So I'm going to rotate the motor for 2 seconds at high speed, then 2 seconds for medium speed, and 2 seconds will remain off. There will be a hold delay of 2 seconds. After 2 seconds, the CCR value will be half. Approximately I take 30,000. Then again the hold delay of 2 seconds, then CCR value will be 0. Then 2 seconds hold delay for 2 seconds remain off. To upload the code to STM32 blue pill using STLink v2 interface, you need to install STLink utility in your PC. For that, you need to convert the code into hex file. To convert the hex file from this project, simply go to projects, then properties. Under C and C++ build, click on settings, then microcontroller post build outputs. Check the box of hex file conversion, click on apply and close. Need to build this program. As you can see, there is no error. Also, hex file is generated. Now I'm connecting the ST-Link to the laptop. Open up the ST-Link utility software. Click on Target, then Program. Browse the hex file. You will find the hex file under Debug folder where you have saved the project. After opening up the hex file, just click on Start. Now need to connect the motor driver's PWM input wire to pin number A8. The motor driver's ground must be connected with the microcontroller's ground. As you can see, the motor initially rotating at high speed for 2 seconds, then 2 seconds for medium speed, and 2 seconds will remain off. As you can see, controlling DC motor is very easy. So next step will be I'm going to add a push button here and controlling spring rotation by pressing push button. When I press push button, it will be rotate for 1 second or 2 seconds. I can adjust the speed by changing CCR value. So let's do it. Before adding the push button, I'm making the base for motor and product lineup for understanding the process. I added a push button with pin V0 respect to ground. Let's move on to the QVID software. Need to declare pin V0 as GPIO external interrupt input, which means it will execute first, regenerate the code. Now, first of all, need a callback function. I take a motor variable integer int motor equals 0. When the button is pressed, it will come up to this callback function and the motor value will be 1. Now in the main while loop, if the motor equal 1, the motor will rotate for 2 seconds. Rebuild the code and upload the hex file again to microcontroller. Let's push the button. Nice, it's working. Just need to calibrate the product lineup with the speed so that it can deliver one product at a single press. Calibrating speed and rotation can deliver a single product. As you can see, it just works nicely. So need to add 16:2 display and 10 kilo potentiometer to adjust the contrast of this display. So let's add the display to the microcontroller. This is the circuit diagram to connect LCD to STM32. You can use I2C method for pin minimization. After finishing connection, need to program it. Before programming, you must attach LCD's necessary file like lcd.h in your project folder. I will give you the necessary file in description. Just copy these two folders into your project folder. After attaching files, you need to close the project from QVID software and reopen the project for new file attached. Simply right-click on your project, then close the project and open it again from the project folder you have saved. Just click on C.project file. As you can see, the LCD's files are included. Then you need to declare these pins as GPIO output for LCD, PA4 to PA7 and PA0, lastly PA2. Pin has been declared and regenerate the code. You need to include those files into this main file. To call the LCD function, write this line of code. Now go to while loop, write LCD set cursor 00. Here first 0 means first row and second 0 means 0 position of the first row. To write any character in LCD, just write LCD write string, creating a refresh rate hold delay of 500 milliseconds, then LCD clear. To display the text, I take character variable char text equal choose product. So text must be in LCD write string. So let's test the display is working or not. If you don't see the text in LCD display, just adjust the potentiometer until you get the clear text. As you can see, text is now clearly showing up. So the displays line up to the controller. Now next step will be adding another two buttons, one of them for confirming, another one for payment. And this button is already in here. It will be used as a choosing button. Instead of real payment, I'm using a push button to understanding the process. So I'm adding another two buttons here, B1 for confirm and A3 pin for payment. Also, I'm taking these B1 and A1 pin as GPIO external interrupt input. Go to GPIO settings, set GPIO pull up, pull down to pull up mode for each input button. After that, let's do some coding for those buttons and LCD. I will give you all files in description. Make sure the interrupt are enabled from NVIC settings. After quite a bit of coding, let's test it out how things are going on. So this is choose button. By pressing it, the display will show the products, and this is confirm button. When this confirm button is pressed, it will go to the payment mode. Suppose I'm choosing chocolate here, then confirm. Now if I press payment button, the motor will rotate. As you can see, it's successfully rotating. Pretty nice. So 50% code is done. What if there is no product in product line? It should be detected by the controller. To detect the product, I'm going to use this eye sensor. This eye sensor maximum object detecting range about 12 to 13 inch. I can adjust the range by this potentiometer. I have already made a video how to make this. You can watch this video on my channel. So this eye sensor will fit in here, something like that, by the help of this supporter behind it. By this position of this eye sensor can easily detect if there are any product or not. So need to join this eye sensor to the microcontroller. This is positive line and middle one is data pin, and this is negative line. So when any object detected, it generates approximately 3.3 volts at data pin, which indicate binary logic 1. By this logic 1, I will write the code. I also adjust the range to whispering size. As you can see, the LED is glowing. I connect this data pin to pin B4, so declaring pin B4 as GPIO input. After regenerating the code, I take integer IR sensor equal 0 and taking another display text product is not available. In callback function, this section for choose button and this section for confirm button. In this condition, IR sensor data pin need to read by this line, and read data value will put in IR sensor 1. I make another IR sensor equal and condition in this function. It means when press 1, which is chocolate, and also press confirm 1 and also IR sensor equal 1, this statement will true, then the display will show the payment mode pay money, else the display will show product is not available. After uploading the code to microcontroller, if I choose chocolate, then confirm it, as you can see the product is not available because the IR sensor is not detected any product. If I put this chocolate, let's see what happened. As you can see, the IR sensor easily detect the product, the LED is glowing. So I'm choosing chocolate again, then confirm. The display is showing payment mode, pay money. Now here's the thing, if I press the pay button, the motor should rotate as I program it. Brilliant, it's working. Nice. To more realistic, I'm adding a buzzer. It's very easy to add a buzzer here. When there is no product, the buzzer will alarm for 3 seconds. So I choose pin B12 as GPIO output. Regenerating the code, I take integer buzz equals 0. Under callback function in confirm button statement, as you know, in else condition will show product is not available. Here buzz value will be 1. When buzz equal 1, it should go to the while loop. As you can see, this code is for display the text in LCD. Here if buzz equal 1, the B12 pin will high by GPIO write pin code and a halt delay of 3000 millisecond. Then B12 pin will be low and the buzz value will be 0 or close the loop. So let's check it out, the buzzer. Choosing again the chocolate, there is no product in product line, then pressing confirm button and the buzzer is alarming, and also display is showing product is not available. Perfect. So buzzer will alarm for there is no product. Almost done. Need to add more 3 motors and 3 IR sensor. For that need to declare some pins and conditions. If I show you now the whole structure, so this is the whole structure without the front side. As you can see, I have already fitted 4 motors and 4 IR sensor behind it. All the wires are assembled underneath this board and it comes out to the side. I also fitted a 6-volt white LED on upper side. As you can see, it looks already very promising. Springs and IR sensors are assembled perfectly. I can easily unplug the springs from the motor and easily can put back again. I level on every single wire for easy connection. Body shape, length and height about 17 inches. and width about 12 inches.
Now moving on to the front design, as you can see I have already cut this shape. I glued a transparent plastic sheet on it for product showcase. Display will fit in here. These two holes for choose and confirm buttons. This is the coin insert hole. The product will deliver into this gate. It can be opened by a little push, and as you can see I already installed a hinge on it, so it will be open up to 90 degree. And this is the coin sensor. If I show you inside of coin sensor,
Payment system is just a switch to ground. I made this contract sensor by cutting a blade. So when any coin pass through this path, it's make a contract between microcontroller's A3 pin to ground. I angle it about 45 degrees because of creating a force to pass through this contract. Soldering two buttons in Veroboard and fix the position in front side. The buttons are not perfectly working. If I press from edge side, the pressure is not hitting the center point of the switch. As a solution, I tape over it and the pressure perfectly hitting the switch in any direction. Also very sensitively working. Nice solution. Attaching front side panel with the help of the hinges by screws. As you can see, the door is smoothly opening. For lock the door, I attached two pair magnet in this side. More strongly, I made a locking system mechanism here. By slide it down, the door is automatically locked in place. I installed a dedicated power switch to operate this machine. Now covering the back side, attaching the display. For keep the coins, I made this beautiful coin box. The coin will insert into this small hole. The box is perfectly fitted in this place. I can easily bring it out.
So let's finish up coding and make this thing functional.
So these are the pin configuration for this vending machine. If I show you the whole program right now, as you can see, these texts are to display in LCD. This is the callback function which operate as interrupt input. These are for start all the timer channel. Additionally, I program the buzzer. When the payment is successful, it will create beeping sound. So this is it for programming. Make sure you are programming below in user code begin. Otherwise, when regenerate the code, the previous code will be erased. I ended up with this circuit diagram in Proteus software. I will give the circuit diagram in description. I'm implementing the whole circuit in Veroboard for a compact size. After 3 hours of designing and soldering, it looks pretty nice. This is DC power supply in, about 7 volts, positive 5 volt connection ports and ground ports, motor connection ports, white LED and potentiometer for LCD contrast.
So Veroboard implementation is done. The whole circuit is now
Compact.
Though it's very time consuming for soldering every single component on it.
For more compact,
You can design a PCB, that will be better. Now time to connection and wire up every single part with this board. So let's do it.
the moment of truth. Here is the final results. So initially the display will show welcome message and choose product. By pressing choose button, the product will change. For example, I choose biscuit here, then confirm the product by pressing confirm button. It will move on to the payment mode. If you have change of mind to select another product, just click again choose button and it will automatically go to the initial stage. When the payment is successful, the display is showing payment OK and buzzer is beeping. Then the display is showing purchase success, item delivered. Now let's choose a product which is not available. I am finishing the dull sector here. As you can see, dull is empty. Now choosing again dull, then confirm. The buzzer is alarming and the display is showing product is not available. Choose another product. Nice. Let's buy all of them one by one. First I'm choosing dull, then confirm, inserting the coin. Dull is perfectly delivered. Next I'm buying biscuit, confirm, payment, and here is the biscuit. Then wafer, confirm it, payment successful, and here it is. Last one, the dairy milk, confirm the product and payment done. As you can see, it's perfectly delivered. The most satisfying thing is its response time is very fast and it's perfectly working. For a social experiment, we left this vending machine in our university campus to see the students' reaction. So let's see their reaction. I put a buying instruction on the table so that they can easily buy any product from this vending machine.
What is this? Vending machine. Oh, I see. Nice project. Yeah, I find the instruction. Now I will buy a product. Step 1, choose. Okay, let me choose. Step 2, confirm. Okay, confirm. Okay, giving the coin. But where is my product, bro? Where is my product? Give my money back.
Students were very excited to see this small vending machine outside. Sometimes they fail to operate this machine. When they successfully purchase a product from it, they seem like very happy to receive it. Also, our faculty members were very impressed to see such a vending machine project. More likely, they were very happy to see this machine very much functional.
I am going to hack this vending machine using steel scale. Ha ha ha. Yes, I have done it. Yes. Run.
So the main problem or limitation of this vending machine is the payment method. You can buy any product with just a conductive scale. So I'm going to insert the scale in the coin insert hole, just like that. So as you can see, the product is delivered. So this is the hack of this vending machine. So the microcontroller doesn't know which money is inserted. So the real vending machine payment mechanism is very complex. They use image processing system, which is very complex. So this vending machine is just a sample of how a real vending machine works. So that's it for this video. Hope you learned something from this project. Goodbye for now.